That's the question. Find the reactions and these 3 points. So what should I do? Every time we solve a problem, we have to do 5 steps. Choose your system. So in fact, this is one part. This is welded to this main shaft, and this is the ball connector, just a single ball, right? It's pinned to the wall. And this guy here is a ball bearing, right? In fact, if you draw the details of this connector, you will get something like you have ball here, contact with in fact, this is a ball bearing that is in contact with the shaft only through one line. This line is the contact point of the surface of each ball in touch with this shaft. So it's a few points of connection, right? And nothing is engaged, it's just touch. So as you can see, this shaft, you can easily roll it like this, rotate it this way. Also, you can move it like this way or this way. You can rotate it about this axis, this axis, this axis. So about 3 axes, you can easily rotate it. And when I talk about rotation, I'm talking about a small rotation. Small rotation. Why? Because you only have one line of contact. In 2D analogy, it's like that. Consider this shaft, and you have so this is the ball bearing, cut it from the 2D view. As you can see, the point of contact is right here, right? It's just one point. So you can easily nose it up and down, right? But what if I had 2 of these ball bearings? One here, one here. Yeah, you can still do this. You see? Like this way, you can, doesn't matter how many ball bearings you have, you can still rotate it freely this way, but you can't up and down it like this, because this distance is going to create a moment that is going to counter your moment, right? So in this case, this is the difference. So here, in this problem, you only have one ball bearing. So here, you don't have any moment. It's just for force restriction. Okay? Now, I choose my system, step 1. So that's, I try to make it as simple as possible with drawing. So that's going to be going D, B, A, and point C. And then what's the next step? So I use my system, check mark the next step is draw FED. Again, to draw FED, I put that dot line around the system. In fact, don't forget, in 2D, this is simply a dot line like that. In 3D, it's like an envelope. It's like a plastic wrap around the part, around the system. Like you imagine that you try to isolate this from the surrounding. So not only you should go this way, but also you should go around it and consider all part of connectivity to the neighbors, right? So starting from here, let's go around it. At point A, how many force and moment do I have? You ask the question, if I only had this part, just forget about the rest. Can I move it in the x direction? No, so there is an unknown AX that prevents me from easily moving in X. Now you say, can I move in Y direction? No. There is an unknown AY. Can I move it in Z direction? No. Unknown things are preventing me from moving in all the three directions. Now let's go to moments. Can I rotate this part? It's just this part. Just forget about the rest. It's just this part. What? Axis X. Can I rotate it about axis X?
Yes.
Yeah. This is frictionless ball right there. Pinned to the wall. Frictionless. So there is no counter moment in the X direction that prevents you from rotating it. So I don't put the MX here. If I had it, if this was wet at this point, you would put MX first. Now can I move it, can I rotate it about Y axis, just this part? Can I rotate this part about Y axis?
Yes.
Yes. What about Z? Like this, can I rotate it about Z?
Yes.
So no MY and no MZ. Okay? So only three. Only three. Now let's move. The next thing you caught is the 900 force here. Just put it here. You don't need to introduce new unknown. We have it right there. Just put it there. Move around it. The next thing you caught is this guy. Then you ask the question, forget about the rest of it, just consider this part. Can I move it in X?
No.
No, so there is a dx here, unknown. Can I move this guy in a Y direction?
Yes.
Yes, because you see, it's ball bearing. So there is no by. Can I move it in Z?
No.
No, so there is something that resists and you don't know it. Easy. What about moments? We just explained it because we have one line of contact. You can easily rotate it in all directions. It's like the same analogy. Like we had on beam, and then you have one point of contact. You can easily, the only thing we had was FZ, the Z direction. You can easily rotate it. Right? So that's it. I'm done with point B. Now let's walk around it. The next thing I caught, do I have another thing? What about a C?
An X or a Z.
Yeah. Then you ask the question, can I move it in X? Yes. Move it in Y? Yes. Move it Z? No. So you have CZ. Do I know it? No. So just introduce unknown variable. Right? Can I rotate it about the X, Y, Z? Yes. So there is no moment. Okay? What else? Then you walk around, you come here. It's already included. Then you're done.
So C is a ball, basically it's sitting on a ball?
C is a ball. It's like this thing is resting on a ball.
Okay,
It's
okay.
like a touch point. It's
Okay.
not welded or
Okay,
anything.
okay.
Right? So that's pretty much all of it. FVD. Now you don't forget to check mark. Every step you do, you come and check mark it. Now you go to equations. Before I go to equation, can I solve this problem? Why?
There's 7 unknowns, or there's 6 unknowns.
How many equations? Why 9?
Because it's 3.
In 3D, don't forget, in 3D we have summation of force in x0, y0, z0. 3 equations from force, and then summation of x0, moment about y0, moment about z0. So how many equations is that?
6.
So in 3D, you have 6 equations per part or per system. In 2D, we still have 6 equations, but the one that we use is this guy in 2D. So we say we have 3 equations per system. These are not 0, 0, 0, because we don't have any force or moment in other direction in 2D. Right? So let's write it here. So I can solve it. So if I solve it, then I go to the next step. Summation of force x0 ax plus bx is equal to 0. Summation of force y0 ay is equal to 0. Summation of force z0, that's going to give me az negative 900 plus bz plus cz is equal to 0. So these are the force equation and the moment equation. Summation of moment x0. What do I get here? First of all, what point should I choose for my reference moment? My candidates are A, D, B, and C. Which one should I choose as my reference moment?
A.
A. Why? Because it's the only one that has most unknown going to that one. So, according to what we mentioned before, that's the best point to choose. So, I say summation of moment about A with respect to the x-axis 0, summation of moment about y 0, summation of moment point A in the z direction. Okay. 3 moment equation. In 2D, we only consider the z direction. Right, because our moment is only in the z direction. But in 3D, we have to consider other 2 equations too. So summation of moment about point A with respect to the x-axis. Let's start with this. 0, 0, 0, go through A. Now, 900. Then you ask the question, can it generate a rotation about x-axis? The answer is yes. See, it's 900. It can generate a rotation about the x-axis. How much is it?
900 times 0.4.
900 times this is the moment arm, right? Which is, so 900 times 0.4, positive or negative? Negative. Now let's go to this guy, dx. Then you ask the question, can it generate a rotational or moment effect with respect to the x-axis? No, it's parallel. You remember we had concurrent forces, parallel forces. We just ignore it, 0. Go to bz. The moment generated by bz is equal to bz times. What's the moment arm? From here to here, which is 0.8. Positive or negative? Positive. Next, CZ. Does it have a moment or no? Yes. And it's equal to CZ times
1.2.
1.2 and 2. Positive or negative?
Positive.
Positive. Is equal to 0. So that's the first equation, right? Summation of moment about the y-axis. The Let's start with this. 0,
No.
0, 0, 900 times 0.4. Positive or negative? Negative. Next.
No.
0, 0, it goes through axis Y. You know, it's concurrent. It goes through axis Y.
0.6.
0.6 times
CZ.
CZ. Positive or negative?
Positive.
Positive. Is equal to 0. Now, the last thing, final. Solution moment what? Z-axis. Right? Start from this. 0, 0, 0. Z-axis. Right? This can generate a rotation of what? Y-axis or X-axis. Right? But it's parallel to Z-axis. So it cannot generate any rotation. So the moment is 0. Next.
No.
0
0.8.
time 0.8 times
EX.
dx, positive or negative?
Negative.
Negative. Next. Moment coming from is 0, right? Plus 0 is equal to 0. So these are my equations. Now, which one should I start with? 1, 2, 3, 4, 5, 6. Which one should I start solving? Huh? 5. Yeah. So if you get CZ, so CZ is equal to 0.4 times 900 divided by 0.6, which is a positive. In fact, the last step, don't forget, is verification. This CZ should be positive only, because this is just in contact with this wall. So if CZ is negative, which means that this goes this way, the system is not in equilibrium. The only way CZ can be valid, if you have force, CZ should be positive. And that shows a positive value. So it actually, when you verify it, don't verify it right now. Last step, when you verify it, you get, okay, CZ is positive, it's nothing unusual, right? So you get CZ here, then what's the next step? Well, you already know that EX is 0. So the step 1, we can either solve for CZ, BX, and also AY. You already have all this guy. Step 2, now if I have CZ, then I can here, put it here, get BZ. Right? And the last thing, if I have BZ, then I have CZ, then I can get AZ. If I have BX, BX is 0. Then AX is also 0. Alright? Alright.